Hello. In this video, we want to look at some definitions. In this section, we're going to start looking at a couple of identities, and the first couple that we're going to look at are the cosine of a sum. And it basically says that the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Now notice that the alphas and betas stay in the same order, but cosine is not what we would call a linear operator. So in other words, we can't distribute the cosine as an operator to both alpha plus beta. Now, remember, cosine is even. That means that if we have a sum or difference here, we have to have an even and an even added together, or in this case, subtracted. Doesn't really matter. Now, cosine is even. Even times even is an even. That's good. Sine and sine is odd. Sine are both odd, so odd times odd is even. So you have an even function plus an even function. That gives us an even function. Good. In other words, both of these need to be the same cosines or sines, and remember that cosine comes first. So if we're working with cosine, you see cosine for both of those. Now the same thing happens with the cosine of a difference. Cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. The difference is that the cosine uses the opposite sign between the two. So cosine is alpha minus beta, gives us a plus in between, and cosine of alpha plus beta gives us a minus between. Good. And then we have cofunction identities. Now, sine of pi over 2 minus u is cosine u, tangent of pi over 2 minus u is cotangent u, secant pi over 2 minus u is cosecant u, cosine pi over 2 minus u is sine u, cotangent of pi over 2 minus u is tangent u, and cosecant of pi over 2 minus u is secant u. In other words, there is a phase shift between everything here, and sometimes a reflection. Alrighty. Well, I'm going to go ahead and end it here. I will prove these in class, so we don't have to worry about that right now. But for now, let's go on to the next video and see what it holds for us. I'll see you there. Have fun.